Okay, our last example in section 4.5, applied optimization, is the following. Example 68. Let's read the problem. A rectangle is to be inscribed. Inscribed means all contained within a semicircle of radius 2. What is the largest area the rectangle can have, and what are its dimensions? So here's a semicircle of radius 2, right? A circle of radius 2 would be x squared plus y squared equals 4. So if I solve that for y, I get y equals the square root of 4 minus x squared. I'm taking the positive square root, so I'm looking at the upper half of the circle x squared plus y squared equals 4. That's the function. I want to inscribe a rectangle inside of there. Okay? So the height of that rectangle will always be the value of y, whatever the y value is on the function. And then the length of that rectangle will be, well, from here out to the tip of it is x, so I need 2 x's, right, to cover the entire length of that rectangle. So the area of the rectangle is 2x, the length, times the height, y, where y is the square root of 4 minus x squared, so I plug y in for there, and now up here I have area as a function of two variables, x and y. Since I know y equals the square root of 4 minus x squared, I can plug that in, I get area as a function of one variable x, 2x times the square root of 4 minus x squared. And we now can say that x is in the closed interval 0 to 2, right? If I bring x all the way down to 0, sure, I can do that. Physically, it wouldn't make sense. I know that that's not going to be a maximum area because that would make my base 0, but that's okay. I could also push it all the way out to 2, but that would shove y all the way down to 0. So I also know that that won't give me the max area of the rectangle either, but I can have enclosed interval, which makes it easier. I don't have to take the limit. I can just evaluate it at the endpoint. So the area is this 2x times the square root of 4 minus x squared. Take the derivative of this and be careful. I got to use a chain rule, right? First times the derivative of the second plus the second times the derivative of the first. Simplify this after doing some algebra and simplifying. I get 8 minus 4x squared over the square root of 4 minus x squared. Now, this equals 0 when the numerator is 0. So when is the numerator 0? When x squared equals 2, which means x equals the square root of 2. I don't need the negative square root of 2 because I know x can only be between 0 and 2. And it's undefined when 4 minus x squared equals 0 or x equals plus or minus 2. So it's undefined at x equals 2, but that's an endpoint, so we're not going to call that a critical point. So the only critical point is x equals the square root of 2. Check in the endpoints and the critical point. Check at x equals 0 and x equals 2. Intuitively, we already saw that the area becomes 0. Plug it in, though, to the area function. You get 0. So at x equals square root of 2, the only critical point, area is 2x, which is 2 square root of 2, times 4 minus x squared, which is square root of 2 squared. So you get 2 times the square root of 2 times 4 minus 2 square root. So another square root of 2. So this whole thing comes out to be 4. So that's your maximum area. Your maximum area is 4, and the dimensions of the rectangle then, the length would be 2x, which is 2 square root of 2, and the height would just be y, which is 4 minus x, square root of 4 minus x squared, or square root of 2.